welcome back to the channel. I'm the GCSE science teacher, and in today's video we're going to be continuing with our studies of electricity. This is part of the physics GCSE curriculum. We are focusing today on series and parallel circuits and going through some key definitions that will help us understand this topic more. If you do find this video helpful, stick around and join our community by subscribing. You can also find more videos and content from me on Instagram and TikTok, where I go through lots of revision material in terms of biology, chemistry and physics at GCSE. And if there's anything you want specifically covered on my YouTube in more depth, feel free to just let me know in the comments below. I'm more than happy to make content that is suitable for you and your needs as a student. So let's go starting off with the key definitions. So what actually is current? I talked about this in a previous video, but current essentially is the flow of charge or electrical charge. And this comes from the delocalized electrons that are found within the metal that make up the wires. And because those electrons are delocalized, they're free to move, and that allows for electricity to flow. Voltage or potential difference is the push given to those electrons. Essentially, the voltage, if we were to define it, is the difference in electrical potential energy between 2 points in a circuit. So it's very much linked to forces and energy. And essentially, a way to visualize it is voltage. If you increase it, it gives the current the push it needs to get around the circuit. So if you have less potential difference or less voltage, the current flows less easily. And resistance is very similar in the fact that resistance actually prevents or obstructs the flow of current. So a very high resistance will actually prevent current from flowing through, and that can be useful. A lot of components, even if it's something as simple as a filament lamp or a bulb, each of those components will have their own amount of resistance. So it needs to be considered in a series or parallel circuit which components are placed in the circuit, because it will affect the overall flow of current and also the flow or the resistance, I should say. So it's something to consider, and we're going to talk about each of those things now. So series circuits essentially are any single loop of wire that have components within. There are no branches in a series circuit. The current is the same in all parts of the series circuit, but the potential difference is shared between the components. And you can see that here. We've got an ammeter that reads the amount of current that flows. You've got 5 amps that is the same all the way around the circuit. However, in terms of the voltage, it has been shared. So there's a total of 15 volts, but actually each filament lamp receives 5 volts of potential difference each. This is why if we add more light bulbs in a series circuit, the lamps actually become dimmer. And if one of the lamps breaks, that actually prevents the flow of current. It actually stops the entire circuit. And that is something you could get asked to explain or even identify in the exam. A parallel circuit is slightly different. There are branches and they have benefits. A parallel circuit is often used in more complicated circuits because if one part of it breaks, the rest of it will function correctly anyway, because the flow of current has not been stopped in other parts of the circuit. So it can be quite useful. If you think about a parallel circuit, it's actually the opposite of a series. A parallel circuit actually shares current between components, and the voltage is actually the same in this case. So you can see that there is 10 volts of voltage or potential difference, and each of those light bulbs will receive the same amount. However, the current is shared. So if there was 10 amps of current flowing around the circuit, you'd actually have 5 amps of current going to each light bulb. I have a question for you, and it says your cat is playing with some Christmas lights and one bulb actually breaks. You plug them in, but they don't turn on. What kind of circuit are the light bulbs connected in? Comment down below. I'd be very interested to know, first of all, if you have a cat or any kind of pet, but the second one, what kind of circuit do you think this is? Let me know down below. Here are a couple of misconceptions then. So I've drawn terribly some diagrams for you, some circuit diagrams. We have what appears to be a series circuit and what appears to be a parallel circuit. I'll let you decide. What are some of the mistakes you see here? Okay, so here are some of the answers. Remember that ammeters are always connected in series. They won't work if you don't put them in series. If you connect them in series, you may get a reading, but it won't be a correct one. And a voltmeter, however, needs to be in parallel to the component you're trying to measure the voltage of. So In the case of a light bulb, you want to make sure that the voltmeter is actually connected in parallel to it, and the ammeter is connected next to it in series. Be careful though if you do see something like this, because sometimes students will confuse the voltmeter as a parallel circuit. This is still considered a series circuit. The light bulb is still in series. It's just the voltmeter that's in parallel to the light bulb. So just be very careful when you are looking at circuit diagrams and what they're asking for in the exam. But I hope that was helpful. If you did find it very helpful or even somewhat helpful, feel free to like, comment, and subscribe. Share this with someone else you think would also benefit from learning more. I have lots of other revision resources on my YouTube and TikTok and Instagram, so feel free to check out those on there as well. And that's it from me. I've been the GCSE science teacher, and you have been curious. Thank you for your time, and I will catch you in the next one. Bye.